This is my second video on my module on finding measures of central tendency. In this video we're going to focus on finding the average again, finding the mean, but of grouped data. Okay, so that is data as you see here on the right that has already been grouped into a frequency distribution. And the main issue here is when we work with group data, essentially we do not have the raw data, or at least in this case we say I don't have the raw data. So what does one do when they're asked to find the mean, which is go add everything up and divide by however many there are, when you don't actually necessarily have the original raw data, okay? And so we'll just kind of outline the process for doing so and why we do the things we do and actually come up with the calculation here. So we say when finding the mean of group data, we need to utilize the class midpoint for each class. So we're going to stop and kind of talk really quickly about the class midpoint, but recall that the class midpoint for each class, we write it as x sub m, but it's defined as the average of the upper and lower class boundaries for a particular class. That is, basically if we take a trip back over here again, we say 5.5 up to but not including 10.5. What's the midpoint of these two numbers? We could find this easily, the midpoint of two numbers is just the average of these two numbers. So we say 5.5 plus 10.5, 16 divided by 2, of course, is 8. Oops, 16 divided by 2 is 8. So we'd get 8. 8 is our class midpoint here. Let me use a darker color. So we say 8 is our class midpoint here. We want the class midpoints for all of these, okay? So just really quickly, in order to find the class midpoints, we could average, each class's lower and upper class boundaries. So for instance, if we said like 10.5 plus 15.5 equals divided by 2, you'll see that we get 13 here. So we say 13 is our next class midpoint. But what I want to bring up is this. You'll notice from 8 to 13 it went up by 5. This is what we refer to as our class width. And we could determine the class width over here. We say plus 5, plus 5, plus 5. If we already know the class width, technically we only need to find the first class midpoint. Then we could just keep tacking on the class width, because the distance from lower class boundary to lower class boundary would be the same as the distance between midpoint to midpoint for each class. So in other words, add 5 to the next class, we get 18. And 18 looks like it could be between 15.5 and 20.5. 18, 23, 28, 33, 38. Apologize for the handwriting here. But these are all of our class midpoints here, okay? But let's go ahead and go through the formula for finding the average of group data. Recall that average we represent with this x bar. This is how you would read this. We say x bar, and it represents the average for a data set here. But to find the average of group data, what we're going to do is this. We're going to use a sigma, or sum all of the frequencies times the class midpoints. Add all those up and divide by however many there are. Okay, how many total things there are. So let's talk about a few things, starting with n here. How do we find the number of data when I'm not being given this? Well, suppose we could read this here. We say, let the following group distribution represent the total number of miles run during 1 week for a sample of 20 runners. Okay, so we can see easily that there are 20 runners here. But I want to find the mean and tell what it represents. The other way we can find the mean is we can actually just sum up all of our frequencies here. So like 1 plus 2 is 3, plus 3 is 6, plus 5 is 11, plus this is 15, 18, and 20. We say n in this case is 20. And you'll notice I'm using a lowercase n to represent the number of data in a sample. Okay. The next thing I want to consider is this. We don't have the raw data here again. Okay, so what could we do? Well, one way to interpret this is this. We could say, well, we have one runner that ran somewhere between 5.5 up to, but not including 10.5 miles in this week, okay? Since we don't know what this runner has run, what we'll instead do is this. We say, well, I can assume they ran 5.5, but that would be low. I could assume they ran just under 10.5, but that would be high. We're going to assume they ran the class midpoint. So essentially what we're doing here is we're saying this. We had one runner that we'll assume ran 8 miles in this week. In the next class, we'll say we have 2 runners here. These 2 runners ran probably, somewhere around the class midpoint is 13. So 2 13s. The next class we have 3 18s. So we say 18, 18, 18. We have 5 23s in the next class. So we say 23, 23, 23, 23. And then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put my fifth 23 down here. We say 4 times 28, so we say 28, 28, 28, 28. We'll assume 3 people ran 33 in this class, so 33, 33, and 33. And in the last class, we had 2 people run 38 miles in the week. So forgiving the handwriting again, here's what we could do. We could find the average of this data, which is essentially what we're going to be doing. But I want to talk about why we use this formula right here. And essentially, you'll notice that I've added in a 4th column on our table here next to class midpoint. We say this column represents my frequency times the class midpoint. If I wanted to add up all this data that I've written out here, which would be construed as the raw data, we could say we had 1 8, 2 13s, 3 18s, 5 23s, 4 28s, 3 33s, and 2 38s. An easy way to do this would actually be to just take the number of each of these class midpoints and multiply them out and then add that stuff up. So in other words, when I say frequency times class midpoint, we're saying we had 1 8. So 1 times 8, we had 8 there. If I'm adding all these up, I said I have 2 13s. Well, 13 plus 13 here would be 26. Or we could just say we had 2 people that ran 13. So I get 2 times 13. So I get 26. Okay, so 26. So our method here is going to be just multiply frequency times class midpoint for each class. So 3 18s would be 54. 54 here. 5 23s would be 115. 4 28s would be 112. Get this out of our eyesight here. 3 33s, that's 99. And then 2 38s, that would be a 76. Okay, so what we need is we need the sum, according to our formula, of this entire column. And it's just kind of an appropriate thing to do is put your sum down at the bottom. So the sum of this entire column, we'd abbreviate it this way, would be what we get when we add all these up. And so we'll just go ahead and get our calculator out here. We say add all these values up here. We have an 8 plus a 26 plus a 115 plus a 112 plus a 99 plus a 76. Okay, so we say 436 happens to be our sum here. So 436. So just like we would in a typical instance, we would find the average of these. Actually, let me check this again. I think I forgot a number here. We say 8 plus 26 plus 54 plus 115 plus 112 plus 99 plus 76. Indeed, I did whiff on that one. So we say 490 is our sum here. So to find the average, we say x bar is our sum of our frequencies times class midpoint split 20 ways. And again, we could just use a calculator to do this here. We say 490 divided by 20. So 24 and a half. So we're going to go out one extra place value, 24 and a half, and this is miles run. Miles ran is past tense, is our average for this data set here. So what does 24 and a half represent? Well, a few things. We say it's a central tendency. So we'd say this is kind of where the data tends to be in the middle of my data set. So 24 and a half, you could see that that would lie in this class right here, and that we had a lot of frequency around the middle of these kind of values here. It is also the most typical case. So it's not necessarily the truth that somebody did run 24 and a half miles, or that everybody did, but it describes on a typical case, on a typical week, that's what happened. Okay, so 24 and a half miles, all right. So I just want to point one thing out here. We say the procedure for finding the mean of group data, we assume that the data in each class were actually equal to the class midpoint, and that this is highly unlikely and therefore causes the mean that we find to be only the most optimum approximation. So this average here is not the actual average, but is a very close average, okay? And the reason why is because we don't know that everybody ran exactly the class midpoint, but that's the best guess we could get. So this is kind of the procedure for finding the average of grouped data. Cheers.